Hello, we are here for one more lesson of the T-FLEX analysis training course, and the topic for today will be something called loads compendium table. This will be a little different um, lesson. Today I will show you a resume of the different types of loads and related topics with each type of load. It's a resume, and I think it's something that it may help you because in case of need you can consult this video to see some resumed information instead of going back and forward looking for some topic or some detail that you may need. So starting with this, um, I will show you this simple table, load type, where we can apply the load, which are the objects that are related with this type of load, and the input parameters that we need to give to the system. So first one, it's the basic concentrated force. We can apply it on a vertex. We have objects selected for direction definition and local coordinate system, and we need to give units, and we give also a force. Then we have the uniformly distributed force. So in a face or an edge, the objects are the same, but we need to give also the normal to the face, and the parameters are equal, so units and force amount. A non-uniform force, we apply it on the face. The objects are the same as the previous one. In here we give the units, the force, and the distribution law. Just a brief note that I've inserted an image that tries to exemplify the type of load that we are talking about, and the corresponding icon where we can apply that particular or specific load. If you see in these three first ones, the icon is always the same, because when we go inside force, we have several types of loads that we can apply depending on the parameters that we choose. So we have also under the same icon bending moments. We can apply them on vertices, faces, or edges. We have a related object which is only the local coordinate system, and the parameters are the units and the magnitude or the amount of the value regarding the moments. Now in pressure, uniform pressure, so face or edges. So we need to define the direction selecting objects, local coordinate systems, and a normal to the selected face. Parameters, units, and pressure amount. Non-uniform pressure, so face, the same as the previous one. This particular case, it's a little different because we give a pressure distribution law. Hydrostatic pressure, so face and a local coordinate system. In here we give the fluid density and the units. Then we move to a different type of load. In this particular case, the centrifugal force. We apply it on a body, and we have the objects for defining the axis and LCS. In this particular case, we give an angular velocity and angular acceleration values as the unit systems also. Now acceleration, we apply it on the body, similar to some of the previous ones. So objects for defining the direction, and LCS. Parameters, unit system, and the amount of acceleration that we have. And a different type of load, the bearing force, we apply it on a cylindrical face like shown on the image, equal to the previous one, so defining direction, and we have the local coordinate system, and we give also the units and the force amount. Torque, we apply it on a face equal to the previous one, and units and moments amount in parameters that the user inputs. We have another type of load called additional mass, so we apply it on vertices, edges, or faces. The related objects are the ones that allow us to define the axis of gravity, and we have also related a local coordinate system. Inputting parameters, unit systems, and mass value. Now, oscillator type of load applied on vertices, edges, or faces. We have only local coordinate systems, and in parameters, units, displacements, and velocity or acceleration. Moving to the final round of loads, thermal loads. So load type temperature, we apply it in several types of locations. So body, faces, edges, or vertices. We don't have any related objects, and we need to give only the magnitude of the load and the units. T-FLEX, we apply it on a face, again no related objects, and parameters to input, magnitude of load, and also units. Heat power, body, face, edges, and vertices as application locations, again no related objects, and parameters, unit system, and heat power. Almost ending. So convection, we apply it on a face, no related objects again, and we need to supply the system with the heat transfer coefficient, the temperature of environment, and the units. And I think it's the last one, so radiation. We apply it on a face, again no related objects, and parameters, a lot of them. So radiation type, emissivity, temperature of the environment, units, radiation view factor of a phase. And I think it's the last one, yes. So this is a resume of type of loads and these object applications. I hope this is information that helps you in case of need for the future. This is a complement of the videos, you know, these lessons, but also the videos where we show examples for different cases and different types of loads. Anyway, in case of help, you may give us a contact, and we will give you all the necessary support.